Hi everyone. When it comes to deploying this AI model and building end-to-end AI-based data pipeline and creating the real-time applications out of AI model, one tend to implement what they have learned onto the AI bootcamps. I do believe that AI bootcamps are a great way to start your AI journey, but then when it comes to end-to-end application development, leveraging AI models, one need to learn a lot more. For example, how to deploy the model or even where to deploy the model, how to create this end-to-end pipeline so that AI model endpoint can be consumed, and how to secure everything. So let's start with deploying this AI model and that to where to deploy this AI model. So when it comes to deploying AI model, we have many options available. For example, all public clouds like AWS, Azure, GCP, all provide some sort of service where we can deploy this AI model seamlessly. We also have these small cloud providers like DigitalOcean, for example, that to provide pretty good options rather to actually deploy this AI model. All right, so let us start with the comparison. Like I mentioned earlier, we have all the public clouds available, as you can see in the first table. So AWS SageMaker, some of the pros are it can be integrated with AWS ecosystem pretty well. It is always scalable and it supports entire ML ops pipeline. Some of the cons are obviously it is of high cost and initial setup is complex. The next one is Azure ML or Azure Machine Learning, that how they said, and it provides the excellent enterprise integration. It is always secure and it is very friendly to Azure DevOps. So if you are already leveraging Azure DevOps or even GitHub Actions, having Azure ML will give you an edge. Again, it has this steeper learning curve, so it is not very simple to learn. The next one is Vertex AI from GCP, and it has the native support for TensorFlow. So if you are a TensorFlow fan, GCP Vertex AI could be a right choice for you. It also supports this BigQuery and it is also highly scalable. The one of the cons, and again this is my own personal opinion, but what I observe is the interface is very less intuitive. You have to actually go yourself and figure out if you are using it for the first time, and it takes hell lot of time out of it. So so these are some of the public clouds. Now, like I mentioned earlier, we will examine DigitalOcean because I personally use that for a couple of my projects. Right. So DigitalOcean, what I found is it is simple to use. It is very, very affordable, and we will see some of the price comparison down the line later. And it also provides the container native support. So that are some of the very important pros of DigitalOcean. It has though lacks built in this AI ML specific services. So you end up building services by yourself, and then you will do a lot more configuration, you will do a lot more integration, right? So it again all depends upon what are your situation, what are your scenarios. Again, if you are working for a company who has already decided which platform to use, you don't have much saying. But if you are at a position where you can make some decision, or if you are running your own company and you are trying to build some AI ML based application, this information comparison might be very useful, I believe. Now, very important point, like I mentioned before that GPU power are not cheap. Here are some of the pricing comparison among all the providers. So this AWS SageMaker. Now, before I go to the specific, we need to understand their pricing model. So each of these platform, most of them are charging you three part. First one is the hosting of this model. So that is based on the hourly rates. Then there is a storage pricing. They charge you per GB per month. And then the third portion is the API invocation. So if you invoke API number of times, your cost will increase. So you have to keep all these things in mind, right? So for example, AWS SageMaker, their per hour model hosting cost is 10 cent, somewhere between 10 cents to $1.25. And it all depends upon which kind of GPU power you are using. But cheapest, let's say you are doing some kind of proof of concept work, you still end up paying 10 cents per hour just for model hosting. Then you have storage cost. So it is like 0.023 per GB per month, right? And then when it comes to API invocation, it is again 0.005 or 0.005 per thousand API calls. So most of these public clouds like AWS, Azure, GCP stands within the same range as you can see. However, when it comes to DigitalOcean, you are paying flat monthly fee for your model hosting, which is great because now you know that how much you are going to pay. They are charging you though 1/10 of cents per GB per month of storage now, which is almost half price for compared to all these public cloud. And then a $0.003 per thousand of API calls. So comparatively, DigitalOcean comes out very cheap. Again, there is a trade-off. So for example, you may end up paying more in terms of integration. You may end up paying more in terms of configuration because you may end up hiring a resource or you may put your own effort. And if you calculate your effort to the dollar amount, it is going to be comparable. So choice is yours. These are your options. Now, just to give you a high level idea what difference it makes in terms of per month cost, I have done some uh, scenario based pricing. So for example, let's say we are deploying a model with sentiment analysis API and roughly it has like 50,000 requests per day. And then we are storing like 20 GB of model data. So based on this particular scenario, you end up paying costs like this. So if you are using AWS SageMaker, you end up paying roughly around $224 per month. With Azure ML, almost same, 236. GCP Vertex AI, almost same, 225. However, big difference over here is DigitalOcean, which is somewhere around $13. So there is a huge gap in cost. However, like I mentioned earlier, you may end up paying your money to your resources or you end up putting your own effort. So always it is comparable. All right, so these are some of the basic things that one should know before even deciding this AI deployment platform. Once you know all these things and then you decide this AI platform, next step is actual deployment. So in my next video, I will show you how to actually deploy any AI model. So when it comes to deploying this AI model, you can deploy this model to any GPU-based virtual machines. You can deploy this as a container, or you can deploy this model onto S3 or the Azure storage, and then run, or even rather download during the runtime onto the GPU-based instances. For sake of simplicity and then following the standard practice, I would go with deploying this model as a container inside this Kubernetes cluster. All right, so now what you see on my screen is a very simple Python-based code which is actually acting as a model. And then this particular code, I am going to containerize it, rather this Docker based container. So this is my Python code that I'm going to container. This code basically predicts some series based on this input data. So this acts as a model. And this one is a typical Docker file, which essentially is installing all the libraries required for this particular container during the runtime. And this is my YAML file for Kubernetes configuration, right? So these are the ready-made files. And then what it does is basically these are some of the bash commands. So first step is actually I'm just importing required libraries. I am actually building my Docker based on the Docker file that I showcased. I then tagging it, and then I'm pushing it into this Docker hub. And once it is pushed onto the Docker hub, I'm creating this Kubernetes cluster, and then I'm deploying it. And the very last step is I'm creating this ingress endpoint from my deployment. And these commands will essentially deploy this container into this Kubernetes cluster, and then we will have our endpoints available for consumption. So another cool technique is to reduce cost significantly regarding the hosting of the model is you can store this model onto AWS S3 or the Azure storage and download this model at the time of execution. This may add up some of these cold starting time. However, the cost will be reduced significantly. So in this particular example, so I'm going to show you how you can download this model at the runtime and then consume. Essentially, we are using this Boto 3. What we are doing is we are basically downloading this model from S3 and then using this particular model in our code, and it can be consumed like any other model. For example, this particular URL, we are just making this REST API call, and this API will serve the output. So this is another technique for cost saving. I can drill down further. I can optimize this further with various storage classes and caching mechanism, but that is not something I would want to go right now, because I just want to make sure that you guys understand these basic concepts, and then I don't want you to overwhelm with so much of techniques in very first session. Now once you deploy the model, the most important thing of it is like how to secure everything. So there is various ways of securing this model. Right now, some of these methods are pretty straightforward. For example, how you can secure your endpoint. So it can be some sort of authentication token, like you secure any other API endpoint. But there are some other ways that hackers, but there are some other ways where people can go and do some sort of injections, and that can actually even mingle with your operating systems, right? So let me demonstrate you what can go wrong and how we can secure with a simple Python based coding model. So obviously we have deployed these onto the public cloud or the similar environment. We must have to secure everything. Now, some of the securing techniques are pretty straightforward. For example, you can secure the endpoint with the authentication like you are securing any other API endpoints. There are certain advanced technique that one should aware of, and I'm just going to demonstrate quickly how to avoid some of these attacks. All right, so when it comes to securing this AI deployment pipeline, we need to consider certain key factors. Now, I'm just trying to outline some of the basic key factors that can act as checkpoints, right? So, for example, data security, we need to make sure that data are encrypted in transit and at rest. Then the access control. So, we have to have user role based access control. We call it RBAC in Microsoft World, we call IAM based access in AWS, and so on and forth. But the idea here is everything needs to be access control. The models needs to be secured. So that's where we are talking about storing these models inside the S3 or the Azure storage with proper security based policies, and again the access control. Now, input needs to be validated, it needs to be sanitized, and this is to prevent these injection attacks. This is also true if you are using LLMs onto your code or any other Python code. We need to prevent the injection attacks. Now, this is a very wide topic and we can certainly cover in upcoming videos. But here, just take as a checkpoint that we need to check our code whether it is vulnerable to any injections. Now, monitoring and logging. So if something happens, we need to react immediately, and that's where, as we all know, monitoring and logging uh, comes handy. So we need to log as much granular as possible when it comes to consuming AI model, specifically if these model endpoints are publicly open. Then there is a dependency management. So all the dependencies, all the packages that we have imported in our code, we have to make sure that we are using trusted sources only, and we have to scan all our dependencies. Most of the times when we deploy onto the Docker, they are automatically scanning, but we cannot just rely on that, and we need to take extra step to make sure that we are scanning all the dependencies. And obviously, wherever we deploy this model, wherever we create the pipeline, we need to make sure that we apply all these standard network segmentation and other practices, having security groups, VPC, private subnet, and so on and forth. These are some of the code example. So most of the times when we are trying to load the Python objects, we tend to use pickle or .pkl file, as we call it. And most of the times, or many of the times, this loading the objects through pkl file can be very dangerous. And just to avoid that, there is another way of loading this object. So that is something called joblib. And joblib is specifically designed for serializing Python objects that contain the large data. So anytimes if we are using .pkl, we need to make sure we try using joblib. So these are some of the basic security concept that we must implement. We must use it as a checklist. And as I said before multiple times, that we will deep dive on each of these. So for now, let us stop here with all our security considerations required for these AI pipelines. All right. So in today's session, we mostly learn how we can deploy the model, how we can consume the model, how we can basically create end-to-end pipeline with AI model, and how we can secure everything. Now, again, this is a very basic details. We will go in depth of each of these components in upcoming videos. We will also cover many more advanced AI topics. So please stay tuned, and bye for now.